In this video, I'm going to explain JavaScript generators without going through any asynchronous programming example. Because JavaScript generators, even though they're used for making asynchronous programming simpler in JavaScript, they are a concept by themselves. They can be explained without going through the complications that asynchronous programming brings. So I think it's worth understanding them by their own. That's what we're gonna do. So for that, let's write some code. So let's start by defining the simplest possible function, an empty function. And we can, better than this, let's put it the result that it returns on a value. And yeah, it's undefined as expected. So this is a function. It runs, it returns a value. Let's return 5. Generator functions are more complicated than that. To indicate that a function is a generator function, we put an asterisk. This is in JavaScript. Other languages have it differently. And now the generator function, when it is called, doesn't do anything. It returns a generator. So let's call it generator. Generator is an object and it has the next method. And that method is going to execute the first step of the generator. And yep, we don't see anything because it still returns. Yeah, we're logging the generator. We should put some side effects in our function. Let's call it step 0. And so this is what's happening here. When you call f, nothing happens, but it returns a generator object. Then you can call next on the generator object. It returns a iterator. This iterator contains the value that was, in this case, returned here. It also contains a boolean that indicates whether the generator is done or not. But this is still just like a normal function. The fun starts when you use the keyword yield. So you can yield 4 here, for example. And let's say step 1. So here we run, when you call next on the generator, we run step 0, and the it contains the value 4. That was the value that was yielded. Now the done says false, which means that we can call generator next again, and we're gonna get different values on the iterator. Yeah, so we run step 0, we yield 4, it's not done yet, we call next again, we run step 1, it returns 5, and it's done. So what's happening here is that yield indicates a checkpoint, let's say, in the function. Like you call next, it executes until the first yield. It executes the expression as well, evaluates this expression. It could be more complicated, it could not simply be a 4, and returns, let's say, the iterator containing the value 4, but it also says that it's not done yet. Like it says if you continue calling next, there's more work to be done and there are more values to be yielded or returned. Let's make a function that runs a generator. Let's say, let's make a function that iterates on a generator. So let's call it run, and it takes a generator, and this is how this function is going to be called, like this. Does nothing, but everything works. And so here, yeah, we gonna run the first iteration on the generator, and here while it done, while it's not done, we call gen next. Now when you run it, we run all the steps of the iteration. And what if we put more steps then? What if we yield 5, yield 6, yield 7? Oh, I should have said step 2, step 3. So it's running all the steps. Let's also dump the iterator for every iteration. So first step, it yields the value 4, not done yet, then value 5, value 6, value 7. It says it's not done yet here, and then it runs again and says done equals true, but the value is undefined. This is a problem because 7 is the last value we want to give. So to solve that, we have to put a return here, return 7. Because as it was before, it is like it had, that's how it is. When you don't put a return, it puts a return undefined for you. But if we have a return 7 here, this won't run, this can be deleted. And so let's run. Now, much better, it returns 7, so then it finishes the iteration on the generator. So for a quick example of how this can be useful, we can make an interesting infinite function. Let's see, function integers. This is good. So say let I equal 0, and then we make an infinite loop. We yield I, and we can increment it here. And we can put the let here. It's infinite because it has no condition here. So what this function does, if we call it, let's see, let integers gen equals integers. We wanna say iterator equals integers gen next, and we wanna dump the iterator. Unexpected identifier. Oh, because I forgot the asterisk. Not a very good error message. So the iterator contains the value 0, which is the first integer, and done means false because 0 is not the last integer, right? If we keep doing it, let's just copy and paste it. It's going to generate all the integers, and what it's doing is that when it reaches yield, it kind of returns I, but it doesn't really return because it doesn't finish the function. It creates a, let's say, it creates a checkpoint that when you call next again will be executed. So when it runs the first yields for the first time, it's returning 0. But when you call next, it's going to increment the I and finds the yield again and yield the value in I. So what's going to happen if we run this generator? It's an infinite loop. It's generating all the integers as expected because it's never done. And to illustrate better what's happening here, let's put some console logs here. Let's say running integers. Let's current I. It's I. And yeah, let's not do it like this. Let's generate the first 3 integers. So as expected, when the first next is called, console log running integer runs, and it enters the loop, and current I is 0, and then it yields the I that contains 0. So that's why value 0 here, and it's not done yet because the function didn't return. Then when we call next again on the generator, it's going to increment the I, enter the loop again, and print the current I, which is 1, then 2, then 3, blah blah blah. And that's how you can, for example, implement infinite sequences in JavaScript now because of generators. Let's make another exercise related to generators, one that is hopefully more interesting. So I have these 2 generators already. They're already coded, and see that they don't yield any value. It's just steps. So this function, see how it doesn't have a return here, but in JavaScript, when you don't put a return, it's like you have a return undefined. So that's the pattern of all the generators. They yield, and then they return. If you don't put return, it means a return undefined. But you probably never want something like this because you are not really executing anything after the last yield, so you would rather probably have a return here. And a return here means no return. So generators functions think like this. They always have a return in the end. Never let them have a yield in the end. Okay, so we can run steps 1, and we can run steps 2. Okay, so first step from 1, it's we're not interested on the values. We better remove this console log thing, make things simpler. Yeah, so first step from 1, second step from 1, third step from 1, first from 2, second step from 2, third, fourth. Yeah, so that's expected. But this is useless. This is the same as not having any yield or anything. We're just turning generator functions into normal functions. But now that there are generators, we can, after every iteration, run let's run some code after the iterations. So after the steps of the generator function, let's call them a flush. Let's create a function called flush after steps that we call after steps. It's simply let's say flush. And as you see, after every step, we're calling flush. Now that's only possible because of generators, but the nice thing is, what if you want to run the first step from the first function and run the second step from the second function, and only then flush? So that you probably can think about some practical application for this. So let's change our run function. Actually, let's not change. Let's create another function called run together that takes 2 generators. And yeah, so we're gonna define the first iterator, next, then the second iterator, next, and we call flush here. And now, yeah, while not done. Now we have to do while it1 not done and it2 not done. Now I have to check individually. If the first iterator is not done, we call next on it. If the second iterator is not done, actually we call next on the generator. Next. And we call flush after steps here. So let's see how it looks when we run it. Oops, because we're not calling it. Say run together, steps 1, steps 2. Oops, infinite loop. Oh yeah, this should be an OR. Why this one is not done or the other is not done. We're not changing the iterators. Yeah, so that's what we wanted. We wanted to run the functions, the generator functions together. By together we mean we run all the steps from the generators, then we call flush. then other steps, then we call flush. And since the steps to generator function has more steps than the first one, we actually run it alone here, and we call flush again. So this is a good exercise in understanding generators. Another crazy thing we can do here is we can actually create a generator function that acts as a generator for the two generators together. So let's do it like this. Run. Let's call it together steps. And it takes generator 1 and generator 2. And yeah, so we're gonna have the same thing like this. And let's put an infinite loop here. Here we check if iterator 1 is done and iterator 2 is also done. So this means both iterators are done, we return. So that also means the together steps generators is also done, we're returning here. Otherwise we yield. So that means the first step for this function is running the first two iterations on the two generators. Let's call it to see how it works. So together steps 1, steps 2. Yeah, that's correct. Infinite loop. Yeah, as expected, because we're not advancing on the iterations. But let's see the beginning. Yeah, the beginning is when we call this, we run the first step from 1 and the first step from 2, and we yield, so we flush. It's that the flush is the call that we made inside run. But what we really want to do is we want to continue the generator process here. Yeah. After the yield, after the generator runs again, the next step is calling next on the two generators. So let's see how it goes. That's perfect. So with this, we combined the two generators into a single generator, right, that acts as the two generators running together. It's a good little programming puzzle. There's a problem here. We're not. Oh, okay. The problem is I put this head thing here. Yeah, so everything is running as we expect. We can generalize the together steps function into a function that takes an array of generators. We can call them gens. It's a generator function that creates a generator that is equivalent to all the generators running together. We run the first step on all the generators, the second step on all the generators, and so on. And let's use let. ITs are, let's call iterators, are gens, map, gen next. So this is the equivalent to these two statements here. basically saying, yeah, connect on all the generators. We want to run the first steps on all of them. And now inside the infinite loop, we want to check if all of the generators are done. So that means going through all the iterators, and if we can find one that is not done. Okay, this is a little tricky. So find will return true if we find one that is not done. So when you negate this, we get if the Boolean value if all are done or not. So if all done, we can return, just like we do here at the top. And oops. Otherwise, we yield. That means, yeah, we ran this step. We are not going to return yet, but we have to yield because you want to run something before we run the next steps. So now to run the next steps, we're gonna use for each. So here. The for each passes a generator and an index. Should the callback you pass to it. And here we want to call next on all the generators and put the iterators that next returns on the iterators array. I better call it gen. This is the equivalent of these two statements in our function for two generators. So this is how we're going to call it. Together steps 1, oops, we want to pass an array. Steps 1, steps 2, close the array. Oops, an error. Oh yeah, missing a parenthesis here. Oops, JMap, it's Jane's map. For each, oh, each, that's wrong. Yep, so that's the same behavior we got. This can be made more interesting if we pass many more generators here. Let's just repeat them. Let's make this a moot line array. And we can also compose. We can, since together produces another generator, we can do steps 1, let's say steps 1, steps 2, just repeating. Yeah, so this here in the first iteration, we're running the first step from 1, 2, 1, 2, 1, 2, because 1, 2 from this here, 1, 2 from this here, and 1, 2 from this here. So we go run the second step on all the generators, the third step, the fourth step. So here with together we basically created a way to run generator functions in parallel, let's say, but it's not really parallel. It's just that each generator function does a little work, then control is returned to the run function, and it does something. In our case, it calls flush. Then it goes through all the generators again to run the next step. Everything is done together in a sense. It's not multi-threading. It's no concurrency at all, but it's nice way to make functions cooperate. Okay, let's get rid of most of the code here so that we can. Let's review what we've done here. We started with this run together function that took two generators and then called ran them and calling flush after steps for every steps of the generators. But let's delete it. But then we created a generator function that took the two generators and acted as if it was a generator that was generating the two generators together. So to run the function, to behave the same way as the function we just deleted, you can just call them like this and pass the two generators here. But even better than that is if we generalize together steps with a generator function that takes an array of generators and run a step and yields, then run the next steps again and yields until it finally returns. Let's delete this all, and I'm going to copy some more code here. So here I copy and pasted more generator functions that we're gonna use in our exercises. So steps 1 that has 3 steps. Steps 2 does a thing we didn't learn yet. It's a yield asterisk. That this thing is like in the world of functions, normal functions you call functions because they return values and you put the return values on variables. In the world of generators, you can call yield asterisk. That means you're going to put all the iterations of steps 3 inside the steps 2 generator as if they were written here. So that's like when you call functions, and it's like the code in the function was written inside the function that calls it. So you can understand it like that. And yeah, steps 3 is very simple, but does also yield asterisk to the steps 1 generator here. And steps 4 is just a bunch of steps. So in the end here, what we want to do is run together steps 1, checking my steps 1 and steps 2. I always forget this. Oh, this is long. So let's go through this. So we're basically only running steps 1 and 2 again, but steps 1, so from 1 it runs here, the third step runs until here, and steps 2 is also running like in parallel. The first step from 2 runs, then the second step from 2, and here we start running the first step from 3 because of this code here, that like we are using the steps 3 generator. So it's like it behaves as if we copy and pasted the steps 3 code into the steps 2 function, generator function. And yeah, so that's why we start seeing steps from 3. Second step from 3, third step from 3. So at this point, the steps 1 is done, but 3 is the only one running. And then the fourth step from 3, how many steps 3 has? 3 has many steps. And then the steps from 1 starts running, because this is the fourth step in 3 also calls steps 1, and so that's why it starts running there. So now we get the second step from 1, the first step from 1, the fifth step from 3, and boom. Steps 3 finally reach the return. This thing here. Fourth step from 2. And that's it. So that, I hope that you can see the generators are simple, but they can lead to, you can build very complicated things with it, like this together function that takes generators and creates another generator that runs all the generators together, and then you can define a run function that takes a generator and run a step, and after each step calls some code that like flushes some kind of state and that was accumulated from the steps that were running from the generators. Yeah.